question number 11. Consider a cyclic quadrilateral. Without drawing its circumcircle, how can you find out whether the center of the circumcircle lies inside the quadrilateral or outside? What is the best way of finding out? What is the best way of finding out? So without drawing the circumcircle, we have to identify the center of the circle is going to be lies inside or outside the quadrilateral. So they are asking the best way. So we are going to check the angles of a quadrilateral. Okay, if all the angles are less than 90 degree, then the circumcircle lies inside the quadrilateral. If any one angle is greater than 90 degree, that is obtuse angle, the circumcenter lies outside the quadrilateral. Okay, if each angle is less than 90 degree, then the circumcenter is lies inside the quadrilateral, otherwise it's outside the quadrilateral. Okay, so this is the easiest method and does not require drawing the circumcircle. Okay, so in this quadrilateral, if each angle is less than 90 or equal to 90, the center is lies inside the quadrilateral. If any one angle is more than 90, for example here, this is the trapezium, one of the angle is more than 90 degree. For this, if you're finding the circumcenter, it lies outside the quadrilateral. How will you find out the circumcenter? Okay, if the lines are given, sides are given, we have to draw the perpendicular bisector. Okay, you have to draw the perpendicular bisector for both the sides, where both the sides, perpendicular bisectors are intersecting. That is nothing but center of the circle. Center of the circle. Here is coming, lies inside the quadrilateral. For the trapezium, for this, if you are drawing perpendicular bisector, and for this, if you are drawing perpendicular bisector, these two perpendicular bisectors joining here. This is the center of the circle. This center is lying outside the quadrilateral. Outside the quadrilateral. There are two cases. One is inside and one is another side. Okay. So they are asking what is the best way to check whether the center of the circle lies inside or outside of the quadrilateral. If any one angle is greater than 90, definitely is going to be lies outside the quadrilateral. If it's 90 degree or less than 90 degree, it will be lies inside the quadrilateral. Now question number 12. Question number 12. So when two chords intersect, each of them is divided into two line segments. When two chords intersect, each of them is divided into two line segments. Show that if the intersecting chords are equal length, that means the two chords are in equal length, then the line segment of one chords are equal to corresponding line segment of other chord. Here, this is the diagram. We have taken a circle with two equal chords. One is AB is equal to CD. AB is equal to CD. Both are intersecting at a point X. Okay, intersecting point is X. Intersecting point is X. While they are intersecting, they ask us to prove the line segments of one chord are equal to corresponding line segment of other chord. That means this is the line segment AX. So I have to prove AX is equal to DX. First one is AX is equal to DX. Next one is CX is equal to BX. BX I have to prove it. Okay, this is how we can prove it. So for proving this, I have to do the construction. Okay, so for proving AX is equal to DX, CX is equal to BX, I have to do the construction first. Okay, what construction I can make? So I'm going to draw the perpendicular. Okay, I'm just going to draw perpendicular. Okay, perpendicular to AB. Okay, draw perpendicular to the chord AB and draw a perpendicular to CD also. Okay, I can just name it as, so I'm just drawing a perpendicular OM. Okay, OM perpendicular to AB and ON perpendicular to CD. This is the construction we are doing it. Okay, so first of all, for proving this, what I have to prove? We have taken AB is equal to CD according to the question. So I have to prove AX is equal to DX and BX is equal to CX. Corresponding line segments are equal. I have to prove it. For this, I'm just doing the construction. Okay, I have done the construction. So what construction I have done? Okay, draw. Okay, draw OM. OM is perpendicular to AB and ON is perpendicular to CD. This is the construction. Okay, from the construction, we know that if the perpendicular is drawn from the center to the chord, bisect the chord. The perpendicular is drawn from center to the chord is bisect the chord. Correct? AM is equal to BM. We know that the perpendicular, okay, to the chord is bisect the chord. Bisect means it's dividing into two equal half. AM is equal to, okay, BM. We can write as AM is equal to BM. First case, AM is equal to BM. The same way, AM is half of AB. Okay, AM is equal to half of AB. This is first case, first equation. Now the same as ON is dividing into two equal parts. Okay. From this I can say DN. Okay. DN is equal to CN. Okay. DN is equal to CN. Okay. So DN is half of CD. Okay. DN is half of CD. This is my second equation. Now from 1 and 2. Okay. From 1 and 2, I can just say as AB is equal to CD is given as AB is equal to CD is given in the question. So AB is equal to CD means half of AB is equal to half of CD. So from 1 and 2, I can just say that from 1 and 2, okay, right hand sides are equal. Therefore, left hand side, AM is equal to DN. Okay, AM is equal to DN. That is, I can take it as third equation. Now, BM is equal to CM. Okay, BM is equal to CN. Now I can take this is fourth equation. Okay. Now next I have to prove, okay, in the triangle, okay, in the triangle OMX and ONX. So both are concurrent. By using RHS rule, I can say these two triangles are concurrent. How can I say? I'm just taking the triangle. In triangle OMX and triangle ONX, I can prove these two triangles are concurrent based on RHS rule. Why? Because one of the angle is 90 degree, here also 90, radius, and this is a common side. Okay, I can say angle OMX is equal to angle ONX is equal to 90 degree, right angle. Next, OX is equal to OX, that is a common side. Okay, common side. Next, OM is equal to ON. So we know that equal chords are equal distance from the center. Equal chords are equal distance from the center. Therefore, I can say OM is equal to ON. So we have learned the theorem. Okay, equal chords are equal distance from the center. Okay, what you can write? Equal chords, equal distance. Okay, equal distance I'm writing. Okay, equal distance from the center. The theorem we are just applying it. So therefore, I can say triangle OMX is concurrent to triangle ONX. So using RHS rule. RHS rule. If these two triangles are concurrent, I can say MX. Okay, MX is equal to NX. Corresponding sides, MX is equal to NX. Now this is, I can just take it as equation number 5. Okay. Now we have to prove AX. AX means AM plus MX. If I add MX with AM, I'll be getting AX. First proof. Okay. Let me go with the first proof. That means I have to add equation number 3 and 5. So 3 and 5. AM plus MX. Okay. Add 3 and 5. So add 3 plus 5. Okay, so what will I get? 3 ones AM. Okay, AM plus here MX. Okay, should be equal to here DN plus here NX. Okay, AM plus MX. See the diagram. AM plus MX. We are getting as AX. Okay, now we are getting as AX is equal to here DN. Okay, DN plus NX. So now we are getting it. Okay, DN plus NX. We are getting as DX. Instead of this, I can write it as DX. So first proof is over. First proof is over. Now second we have to prove BX. Okay, BX means this is BX. Okay, BX, how we can do it? Okay, from fourth equation we are getting as BM. So BM minus MX, correct? BM from here to here. BM minus MX, I'll be getting BX. Okay, so I am going to subtract 4 and 5. Okay, subtracting, that is 4 and 5. So I'll be getting second result. Okay, I'll be getting second result. Okay, subtracting 4, okay, and 5. Okay, 4, this is 4 BM minus, okay, 4 minus 5. So 4 minus 5 BM minus, so BM minus MX is equal to Cn. Okay, Cn minus Nx. Check the diagram. Okay, Bm, this is the Bm minus Mx. So what are you getting as? We are getting as Bx. So Bx is equal to Cn. This is Cn. Cn minus Nx. We are getting as Cx. Okay, Cx. Okay, that's what we have to prove in. First one, this is Ax is equal to Dx. Second, Bx is equal to Cx. Okay, we got the proof. We got the proof. Right, so now question number 13. Okay, question number 13. So draw a circle in which a chord of 6 centimeter length stand at a distance of 3 centimeter from the center. Okay, so now here we have to draw the circle with chord length 6 centimeter and the distance of 3 centimeter from the center. Okay, let me show the steps of construction. Next, I'll be taking to the construction tool and will draw and show you. Okay, first they have given 6 centimeter chord length. Then distance from the center is 3 centimeter. So how to draw the circle? First, we are going to draw the line segment AB as 6 centimeter. That is nothing but chord. And we are going to draw the perpendicular bisector of AB at M. Okay, from this perpendicular bisector, we have to mark the point O such that OM is equal to 3 centimeter. Next, we will be joining OA with the center O as a center, OA as a radius. We will be drawing the circle. Okay, this is steps of construction. Now I'll be just taking to the right. So construction tool. Okay, chord length is 6 centimeter. Okay, next the distance from the center is given 3 centimeter. Okay, the distance from the center is given 3 centimeter. First I go to draw 6 centimeter as the line segment. I am just drawing the line segment 6 centimeter. A ruler 6 centimeter. This is nothing but my this is my chord of length AB. Okay, I'm just naming as this is AB. AB chord length 6 centimeter. So next I am going to draw the perpendicular bisector. Okay, draw the perpendicular bisector of AB. How to draw the perpendicular bisector? So use your compass, keep the pointer in A, right? And take more than half. Just take more than half in your compass. Okay, this is half. More than half means this much, this much, this much. So you can just take more than half in your compass. Keep the pointer in A. So draw the arc up and down. Okay, draw the arc up and down. Okay, so draw the arc up and down. So with the same measurement, so keep the pointer in B. So draw the arc up and down. Okay, draw the arc up and down. Okay. Now where the two arcs are intersecting. Okay, this is the intersecting point. Now I can join the points. If I join, I am getting okay perpendicular bisector of AB. Okay, this is my perpendicular bisector of AB. It will form 90° as well as it's dividing into two equal halves. 6 centimeter means it will be divided into 3 centimeter, 3 centimeter. Okay. Next, right? We have to draw the circle. Now they have given the distance from the center is 3 centimeter. Okay, distance from the center is 3 centimeter. Take your compass. Okay, keep your compass and mark 3 centimeter. Okay, just measure 3 centimeter. Just measure 3 centimeter in your compass and keep the pointer at the center. Okay, keep the pointer at the center and draw the arc. Okay, draw the arc. Here is drawing. Okay, now this is my 3 centimeter. Okay, now this is my 3 centimeter. We know that the perpendicular is drawn from the center to the chord is bisect the chord. Okay, by using the theorem, we're drawing the perpendicular bisector and the distance from the center is 3 centimeter. That means this should be the center of the circle. This is my center of the circle. Okay, I can just name this as O. Okay, I'm just naming this as O. Correct? And this we can just name it as M. Okay, this point as M. Now O as the radius, use your compass. Okay, now so O as the center. Now O is the center, OA as the radius. Now I can draw the circle. Okay. So now I can draw the circle. O is the radius, OA as the distance, right? OA as the radius, I can draw the circle. Okay. So now this is my circle. Now we can just verify it. Now the chord length is 6 centimeter. Distance from the center is 3 centimeter. Based on the given condition, I have drawn the circle. First, draw the line segment AB is equal to 6 centimeter. Next, draw the perpendicular bisector of AB. How to draw the perpendicular bisector? You have to take more than half, right? And keep the pointer in A, draw an arc up and down. From the point B with the same measurement, draw an arc up and down. Where the two lines are intersecting, okay? We can just join, that is our perpendicular bisector. Next, on this perpendicular bisector, mark O such that OM is equal to 3 centimeter. Now join OA. You can join OA, otherwise just take a measure of OA, keep the pointer in O. So draw the circle. Okay, draw the circle. Question number 14. Show that a rectangle is the only parallelogram that can be inscribed in a circle. Let me show first the diagram. Okay, first. If I take ABCD is a parallelogram. ABCD is a parallelogram. I have to prove ABCD is a rectangle. Okay. How can I prove ABCD is a rectangle? Okay. In a parallelogram, okay, opposite angles are equal. If I want to prove parallelogram is a rectangle, if I prove one of the angle is 90°, then I can say ABCD is a rectangle. Okay. We know that in a parallelogram, opposite angles are equal. Here they have to show that as a rectangle is the only parallelogram that can be inscribed in a circle. Inscribed in a circle means we can just say ABCD is a cyclic quadrilateral. Correct? In a cyclic quadrilateral, we know that sum of two opposite angle is equal to 180°. Okay. Sum of two opposite angle is equal to 180°. So we are going to use two concepts. First, we are just taking let ABCD be a parallelogram inscribed in a circle. ABCD is a parallelogram inscribed in a circle. Since it's a cyclic quadrilateral, we can say sum of two opposite angles is equal to 180°. Angle A plus angle C is equal to 180°. I can take this is my first equation. Okay. Cyclic quadrilateral property. Sum of two opposite angles is equal to 180°. But we have taken ABC is a parallelogram. In a parallelogram, opposite angles are equal. Angle A should be equal to angle C. Okay. Therefore, in the place of angle C, I can write angle A. Okay. So in the place of angle C, I can write angle A. That means angle A plus angle A is equal to 180 degree. This way I'm just taking as from 1. Okay. From 1, instead of angle C, I can write angle A. Why? Because both are equal. Angle A plus angle A is 2 times angle A is equal to 180. Now take this 2 to this side. Angle A is equal to 180 by 2. Okay, 180 by 2 is 90 degree. Okay, I have proven angle. One of the angle is 90 degree. A parallelogram with one of its angle is 90 degree. Automatically, one angle is 90 means all the angles automatically will form 90 degree. So hence a parallelogram is a rectangle. Okay, hence the parallelogram is the rectangle. Therefore, a rectangle is the only parallelogram that can be inscribed in a circle. Now, question number 15 is show that if a rectangle is inscribed in a circle, then the point of intersection of diagonals must lie at the center of the circle. Okay, first of all, you can go with the diagram. So we have to draw the rectangle inside the circle. Okay, rectangle inscribed in a circle. Hmm? So here you have to join the diagonals. Okay, join AC and BD. Here AC and BD are diagonal. Okay. Now next, the diagonal must lie at the center of the circle. If the diagonal should be at the center of the circle. So we have to prove it. So here we are just using the property of rectangle. In a rectangle, diagonals are equal and bisect each other. Diagonals are equal and bisect each other. Diagonals are equal means AC is equal to BD. Okay, bisect each other means right. So that is AO is equal to CO. OB is equal to OD. Here diagonals are bisect each other as well as they are equal. We can say AO is equal to OB, OB is equal to OC, OC is equal to OD. So all are in equal distance from the center. That means you can say OA, OB, OC, OD. They all are radius of the circle. Sorry, they all are the center of the circle. OA, OB, OC, OD. They all are radius of the circle. Okay, then O it will be the center of the circle. Okay, so now we can just write the proof. So first we are just considering let ABCD be a rectangle inscribed in a circle. So let its diagonal AC and BD intersect at O. So we know that in a rectangle diagonals are equal and bisect each other. OA is equal to OC. OB is equal to OD. Okay, diagonals bisect each other means OA is equal to OC, OB is equal to OD. And also diagonals are equal means AC is equal to BD. So therefore we can say OA, that is OA is equal to OB, OB is equal to OC, OC is equal to OD. So this means O is equidistant from all the four vertices A, B, C, D. The point equidistant from all the points on the circle is the center. Okay, equidistant from all the point that is center. Hence, the point of intersection of its diagonal is the center of the circle. Okay, point of intersection of its diagonal is center of the circle. Right, so now next question. Question number 16. Consider all chords of a circle of a fixed length. Fixed length means the chord should be in equal length. What is the shape formed by the midpoint of all these chords? Okay, so we are going to take many chords of equal length and we are going to take the midpoint of all the chords. Okay, so what shape we will be getting it? So I'm just taking a circle. Then I'm just taking equal chords. So here I have taken only few equal chords. Okay, this 1, 2, 3, 4, 5, 6, 7, 8 only I have taken. So we have to draw many equal chords. Next, I have to take the midpoint. Okay, midpoint of all the chords. This is one midpoint, 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 midpoint. If you are drawing many chords, okay, So you can just see, right? So small, okay, small lines. So I can just draw infinite number of chords. While joining all the center of the chords, I'll be getting circle inside. Okay. So this is nothing but concentric circle. Okay, concentric circle, which means, okay, circle with same center and different radius. Okay, circle with same center and different radius. Here, if you draw many chords of the same length inside the circle and mark the middle point of each of the chord, all the midpoint will form a smaller circle inside the big one. The smaller circle has the same center as the big circle. So this is called as concentric circle. So you'll be getting concentric circle. Question number 17. So in a circle with center O, chords AB and AC are concurrent. So concurrent means AB and AC are equal in length. Explain why this statement is true. The center of the circle lies on the angle bisector of BAC. Okay, why this statement is true? The center of the circle lies on the angle bisector of BAC. How can you say this? Okay, we have to take a circle with center O and we have to take two chords with equal length AB and AC. Then we have to prove this condition. Okay, so let me show the diagram. Here, I have taken a circle. Okay, I have taken a circle with the center O. I have taken two chords of equal length. AB is equal to AC. AB is equal to AC. So here what I have to prove? The center of the circle lies on the angle bisector of BAC. Okay, BAC. So angle bisector of BAC. You have to prove. So these two angles are equal. Okay. So what to prove? OA is the bisector of BAC. We have to prove it. How we can prove? If I prove these two triangles are concurrent. So triangle OBA and OCA. If I prove these two triangles are concurrent, so corresponding angles it will be equal. So we will be getting the proof. So first what you can take? So what is given first? Okay, given AB is equal to AC is given. So concurrent means they are in equal length. So first you can just write given. So given a circle with center O. Okay, just write a circle. So AB is equal to AC. This is given. Okay. Now I have to prove OA is a bisector of BAC. So that's what I have to prove it. Okay. So to prove AO bisector of BAC. Okay. To prove, so OA is a bisector of or AO bisect BAC. To prove AO, so bisect, so angle. So that is a statement. Okay. The center of the circle, okay, on the bisector of BAC. I'm going to take two triangle. Okay, for proving this in triangle, okay, in triangle, one is OAB, okay, in triangle OAB and triangle OAC, okay, triangle OAC. I'm just taking two triangle and I'm going to prove these two triangles are concurrent. Okay, how can I prove? We know that OB is equal to OC, both are radius equal, and OA is common for both, equal. Next, AB is equal to AC, already given. Therefore, by using SSS criteria, I can say these two triangles are concurrent. Okay, let me write first. So first, what is given first? We'll write, so AB is equal to AC. So this is given in the question. Next, OB is equal to OC. So that is radii of the circle. Okay, radii. Next, OA is equal to OA. OA is equal to OA. That is a common side. So common side. So therefore, I can say the triangle OAB is concurrent to triangle OAC by using SSS rule. So I have proven these two triangles are concurrent. If these two triangles are concurrent, so corresponding angles are equal. Corresponding angles. So therefore, I can say angle. So angle, this angle OAB, angle OAB is equal to angle OAC. So based on CPCT, corresponding parts of concurrency triangle. Okay, so these two angles are equal. If these two angles are equal, I can say so OA bisect the angle BAC. Bisect means is dividing into two equal angles. Okay, for example, total is 100 means now we have proven these two are equal. This should be 50. This should be 50. That is a bisector we have proven. This angle is equal to this angle. So that is nothing but the bisector. Okay. So as these two angles are equal, I can just say hence. So what do you want to prove? Hence AO. Okay. Hence AO bisect angle BAC. Okay. Angle BAC. So hence proved, that means you can just write the statement. Okay. Therefore, the center of the circle lies on the bisector of BAC. Okay. BAC. Okay. So now next question number 18. So two parallel chords of length 10 centimeter and 24 centimeter are on the same side of the center of the circle. So we have to take two chords. One is 10 centimeter and another one is 24 centimeter. Both should be on the same side of the circle. So the distance between the chord is 7 centimeter. So find the radius of the circle. Okay. Two chords length is given. The distance between the two chords are given 7 centimeter. We have to find out the radius of the circle. Now this is the diagram. So I am just taking two parallel chords. Okay. One is AB is parallel to CD. Two parallel chords of length 10 centimeter. So total AB is 10 centimeter. CD is 24 centimeter. Are on the same side of the center of the circle. Both should be in the same side. Now the distance between the two chords is given as 7 centimeter. So I have to find out the radius. Okay. So radius of the circle. So radius is nothing but, so this is the radius. So OC is one radius and OA is another radius. So two radius we are getting is. So one is this one. Okay. So OC is one radius and another is OA is another radius. So two radius I am getting is. So radius, it will be always equal in a circle. Okay. And here the construction is what? Okay. What construction I am doing is, now this is the construction. I am just drawing a perpendicular. OM is perpendicular to AB. ON is perpendicular to CD. Okay. So if it's a perpendicular means we know that if the perpendicular is drawn from the center to the chord is bisect the chord. Correct? The perpendicular is drawn from the center to the chord is bisect the chord. So AB is 10 means, so this is 5, this is 5. And CD total is given 24, therefore this is 12, this is 12. So according to the theorem, the perpendicular is drawn from the center to the chord is bisect the chord. Right? So here we are getting two right angle triangle. Okay, this is the perpendicular. By the construction I can say this is one 90 degree and this is another 90 degree. So two right angle triangle. I'm just getting two right angle triangle. So first I'm going to take, right, so this distance is given as 7. So I'm just going to take ON. Okay, ON is equal to X. I'm just taking ON is equal to X. Okay. So two right angle triangle. First I'm just choosing in right angle triangle. Okay, in right triangle. So in right triangle ONC. Okay, ONC. ONC we can write, or OCN we can write. In a right triangle ONC, apply the Pythagoras theorem. Actually this is the radius. OC is the radius. And here OR also radius. Apply the Pythagoras theorem. Hypotenuse square. Okay, R square is equal to sum of the other two sides square. Just consider only this right angle triangle. First one, in right angle triangle ONC, the hypotenuse square. R square is equal to, okay, first one is 12 square. Okay, sum of the other two sides square. Okay, 12 square plus here x square. 12 square plus x square. So now R square is equal to 12 square is 144 plus x square, we can take it as x square. I'm just taking this is equation number 1. So next, I'm just going to consider the next right angle triangle. Okay, in right angle triangle. Okay, in right triangle. So in right triangle OMA. Okay, OMA. Right triangle OMA. So the hypotenuse square. Okay, R square is equal to sum of the other two sides square. One is 5 square. So plus other side is x plus 7. X plus 7 the whole square. Now we can just simplify it. R square is equal to 5 square is 25. So here plus you have to use the a plus b the whole square formula. A plus b the whole square means a square plus b square, that is 7 square, plus 2ab. Okay, 2ab. Just simplify it. R square is equal to 25 plus x square plus 7 square is 49 plus 2 sevens are 14x. Now here we can just add these two. Okay, 25 plus 49. R square is equal to 25 plus 49 is, okay, 40, 60, 69, 69, 74. Okay, we are getting a 74 plus x square plus 14x. So we can just take this is as equation number 2. We know that in a circle, radius are equal in length. Wherever you are just drawing the radius, it will be equal. So therefore, I can just equate, right, 1 and 2. Okay, from 1 and 2, from 1 and 2. So radius, it will be equal means, so right, left hand sides are equal, right hand sides are equal. So now 104, right? So now if the right hand side, left hand sides are equal, here also r square, here also r square. So right hand side should be equal. So 144, okay, 144 plus x square is equal to 74 plus x square plus 14x. Now if you are taking this x square to this side, so it will get cancelled, or bring everything to the same side. Okay, so everything to the same side and simplify it. Okay, what you will get? 144. Okay, here minus 74 plus here x square. This it will become minus x square. Okay, next minus 14x is equal to 0 we are getting. So plus x square minus x square 0. Now 144 minus 74. 4 minus 4 is 0. 14 minus 7 is 7. Okay, 70 minus 14x is equal to 0. Now take 70 to this side. So minus 14x is equal to minus 70. Now x is equal to minus 70. So divided by minus 40. So minus minus get cancelled. We can just divide with, okay, 7 table. 2 sevens are 14. 10 sevens are 70. Cancel. Okay, 5. Now x is equal to 5 I got. Okay, x is equal to 5. Actually, you have to find out the radius. Okay, so therefore radius. For finding radius, we can just substitute in equation number 2. Okay, so therefore from equation number 1 implies, what is that? R square is equal to, okay, R square is equal to 144 plus x value is 5. Okay, 5 square. So 144 plus 5 square is 25. 144 plus 25 is 169. So R square is equal to 169. Therefore, R is equal to square root of 169. That is nothing but 13. Okay. So radius is equal to 13. So now question number 19. We came right. So first you have to find the length of the side of the hexagon. First you have to draw the diagram first. Okay. Let me show the diagram. So now this is the diagram. Okay. A circle. Okay. Inside we have a regular hexagon. Okay. A regular hexagon is inscribed in a circle with the radius. This is the radius. This is the radius. So we have to find out the length of the side. Okay. We have to find out the length of the side. So this side we are going to find out length of the side. Okay, so for this I'm just choosing one triangle. Okay, AOB. Okay, AOB is a triangle. And here this is the radius and this also radius. So we can just say AOB is an isosceles triangle. As two sides are equal, I can say AOB is an isosceles triangle. Correct? If it's an isosceles triangle, right? We know that base angles are equal. So this angle is going to be equal. I am going to take this is X and this is also X. Isosceles triangle means two sides are equal and the base angles are equal. So this is central angle will be having 360. Here how many isosceles triangle can be formed? So this is one of the triangle. If I join this, I'll be getting, this is second. Now this is third. Now this is 4 and this is 5. Okay, and this is 6. So total 6 isosceles triangle is forming. So total angle is 360. So 360 divided by 6, I'll be getting this. So 360 divided by 6 is, I'm getting this angle is 60 degree. Okay, this is 60 degree. Right, now I can just go with the proof. So the answer, a regular hexagon divides the circle into 6 equal central angle. Therefore, each angle is equal to 360 divided by 6. So 360 divided by 6 is, we are getting a 60 degree. Now this is 60 degree, right? I can just consider AOB is an isosceles triangle. Okay, so here I can just consider AOB. Okay, AOB is an triangle. AOB is an isosceles triangle. Okay, isosceles triangle. So the reason is, so the radius are equal. Okay, OA is equal to OB. Okay, since the reason is OA is equal to OB is equal to R. So two sides are equal. I can say this is an isosceles triangle. If it's an isosceles triangle, so base angles are equal. Okay, so therefore I can just say angle A is equal to angle B is equal to, I am just taking as this is X. I am just considering as X. Now I am going to use the angle sum property of a triangle. Okay, if you are using angle sum property of triangle, okay, in triangle OABC, angle sum property. Okay, angle A plus angle B plus angle O is equal to 180 degree. This is angle sum property. Okay, angle sum property. Okay, angle A we have taken as X. Okay, X plus 60 is equal to 180 degree. Now X plus X is 2X. 2X plus 60 is equal to 180 degree. Now 2X is equal to 180 minus 60 is equal to 120 degree. Right? So now this is 120 degree. Now X is equal to 120 divided by 2. 120 divided by 2 is, this is 60. Now I am getting X also 60. That means this is also 60. This is also 60. Now all the angles are equal. In a triangle, all the angles are equal. Then this is called as equilateral triangle. Okay, first I have taken AOB is an isosceles triangle. Now we have proven AOB is an equilateral triangle. Equilateral triangle, all the angles are equal, all the sides are equal. Therefore, AB also R. Okay, AB length also R. The length of AB is going to be the radius. Okay, this also R, this also R, this also R. Okay, that is the answer for the first one. Okay, here we are getting, X is equal to 60. So therefore, I can say here, therefore, all the angles are equal. So I can say triangle AOB is an equilateral triangle. Okay, equilateral triangle. So if it's an equilateral triangle, all the sides are equal. Okay, so in equilateral triangle, all the sides are equal. OA is equal to OB is equal to AB. So we have to find out the length of AB. Okay, so AB is equal to R. Okay, AB is equal to R. Here also we can write R. Side length, okay, is nothing but radius. Okay, R. Second one is the distance of each side from the center. Okay. Now, for example, if you are taking this the chord, they are asking this distance from O to this distance they are asking. Okay, in the exam point of view, you can go with the same diagram. For the explanation, I'm going with different diagram. They're asking the distance of each side from the center. Okay, this distance we have to find out. Okay, how we can find out? For this, I have taken the same diagram. So I'm just joining OM perpendicular to AB. Okay, OM is perpendicular to AB. So previous part we just found out this is an equilateral triangle. All the sides are equal, right? This is R, this is R, AB also R. And what can be this one? So this one I can take it as this is R by 2. Okay, total is R, this will be R by 2. For finding this length, okay, this is a right angle triangle. I can use Pythagoras theorem. Okay, in a right angle triangle, I'm just going with in right triangle OAM. Okay, OAM. Apply the Pythagoras theorem. Hypotenuse square. Okay, that is R square. R square is equal to sum of the other two sides square. This is R square plus this is R by 2. Okay, R by 2 the whole square plus this is OM square. OM square only we have to find out. Okay, we can write it as R square is equal to R square is R square by 2 square is 4 plus OM square. Now take this R square by 4 to this side. So it will become R square minus R square by 4 is equal to OM square. So we have to find out the length of OM. So now we can just write it as, just take the LCM as 4. Okay, if you are taking LCM as 4, we will be getting as 4R square. Okay, 4R square minus R square is equal to OM square. 4R square minus R square, we are getting as 3R square by 4 is equal to OM square. So now we can just interchange and write OM square is equal to 3R square by 4. So actually we have to find out only OM length. Okay. OM is equal to square root of 3 by 4 R square. So now 3 is not a perfect square number. We cannot take outs. But 1 by 4. Okay. 4 is a perfect square number. I can take outs. The same as R also can be, R square can be taken out. Okay, so I can just take R square outside means R will be balanced. Okay, 4 outside means so 2 will be balanced. Square root of 4 is 2. Now inside what is that? Root 3 is inside. Okay, root 3 is inside. So this one you can write it as, okay, root 3. So root 3 by 2 R. Okay, so we can just complete this answer as So the answer is root 3 by 2 R. Okay. So root 3 by 2 R. So that is the OM. Okay. OM. Okay. Therefore, we can just write therefore the distance. So distance from the center to the chord is equal to root 3 by 2 R. Question number 20. A quadrilateral MNOP is inscribed in a circle if MN is the diameter. What can you say about angle MOP and angle MNP? So explain your reasoning. So first you have to take a quadrilateral MNOP is inscribed in a circle, mean the quadrilateral should be inside the circle. Then we have to take a diameter MN. So we have to say about this. Okay, so let me show the diagram first. Now I have taken a circle. Inside I have taken a quadrilateral MNOP. MNOP such that MN is the diameter. They have given MN is the diameter. Okay, MN is the diameter. According to this, I have taken MN is the diameter. Now, what can you say about? So they are asking MOP. MOP. So this angle, MOP, this angle, and MNP. Okay, this angle. MNP means I have to join this. So these two angles, what is the connection they are asking? So MOP, this angle, and MNP. So this angle. So we know that angles in the same segments are equal. Angles in the same segments are equal. Now we can just consider MP is the same segment for these two angles. Okay, MP is the same segment. So I can say, so MOP is equal to MNP. So both are equal in length. Angles in the same segments are equal. Right, so now directly we can just write. So that is the answer. So we know that angles in the same segments are equal. Okay, so therefore I can say angle MOP. Okay, MOP is equal to angle MNP. Okay, so which is the same segment? So MP is the same segment. Okay, MP is the same segment. So both are equal.
Thank you for watching. Kindly like, subscribe and share. Thank you.